Hello, welcome back. Our topic that we're going to start today, we're going to introduce the topic of chemistry, all right? And in terms of chemistry, this is still an introductory biology course. So I'm really going to focus on biological chemistry, all right? But in order to focus on the biological chemistry, we do need to go over a little bit of chemical structures, all right? Because in terms of the human body, we are essentially one large walking, talking chemical reaction that is going on 24/7, okay? That's why it's important to understand a little bit of chemistry with biology, all right? And in terms of chemistry and biology, all right, anything that's living has to be made up of matter, okay? And in terms of that matter, we're talking about something that occupies space, it has mass or weight, okay? And really what we're talking about with that matter are going to be the elements, okay? So if you've taken a if you've taken a chemistry class, you may have seen, hopefully, in a chemistry class, the periodic table of the elements, all right? I've got a copy of the periodic table of the elements in the PowerPoint slides for you to look at, okay? And in terms of those elements, okay, we're talking about 92 elements that are going to make up and be a part of the natural world, okay? So good news, I'm narrowing things down for you. Okay, we've got 92 elements, okay, that are part of nature. And what we're talking about really with human life and most life, we've got 25 essential elements, okay? And I think your textbook has a table with some of the more common elements that are required for life. I'm not going to ask you to memorize the entire table there, okay? But there are 4. Notice I'm narrowing things down here. We went from 92 to 25. We're now down to 4. Okay, this is good, right? We've got 4 elements that are most common in the human body, okay? And I'm going to change color here just because I like different colors, okay? Those 4 elements are going to be oxygen, carbon, hydrogen, and nitrogen. Okay, so really what we're talking about here in terms of biological chemistry, we're talking about organic chemistry. And for it to be organic chemistry, we're talking about having carbons, hydrogens, and oxygens involved. Okay, so these are going to be the 4 most common elements that make up the body. Okay, there are 25 total that are needed. And that table in your textbook will have the others. I definitely want you to know oxygen, carbon, hydrogen, nitrogen as the 4 most common elements, okay? And in terms of those elements, in addition to the 4 common elements that we have, okay, there are also going to be some trace elements that are important. Okay, again, your textbook has a table that talk about the trace elements. The difference between, these 4 common elements, these are the most abundant. Trace elements are elements we need very small amounts of in order to function. And the example of a trace element that I like to use, because it's tied directly to something that you're going to learn about in A&P2, is going to be iodine. Okay? Iodine is a trace element, meaning we need a little bit of iodine in our diet because iodine in our body is used to make thyroid hormone. So without iodine, our body can't make thyroid hormone. And that thyroid hormone is important in regulating a number of biological processes that happen within the body, okay? And in terms of that, typically people who lack iodine in their diet, this was much more common back in the 1900s, 1950s, all right? It used to be known, the Midwest of the United States used to be known as the goiter belt, okay? And it was the goiter belt because typically the diet of those Midwesterners was beef-based. Beef or maybe lamb, wasn't fish-based. Fish have a high amount of iodine present within it, okay? That's why seafood should be part of your diet so that you can take in iodine, all right? That disparity has kind of been addressed now because if you go to the supermarket now, you grab that canister of salt, it likely that salt that you're grabbing is iodized salt. So the way that we get around the trace amount of iodine we need to prevent a goiter from forming, and what a goiter is essentially it's a large mass that's found on the neck. Because essentially what's happening, that thyroid gland is found within your neck. And because there's not iodine in your diet, your thyroid, your brain is telling your thyroid to make more thyroid hormone, okay? And in doing that, your body is making more of the hormone or starting to make the hormone, but it can't complete it because it doesn't have iodine. So what you're seeing there is the accumulation of products made by the cells of the thyroid, okay? And in terms of that goiter, it's because there's a lack of iodine in the diet. Now with iodized salt, we put salt on just about everything. Goiters have gone down substantially here in the United States, okay? But that's an example of a trace element that you need as part of your diet. Okay, another example of a trace element that you need is going to be iron. Iron is associated with red blood cells. That iron incorporates with hemoglobin to help transport oxygen. Okay, so those are just a couple examples I have of trace elements. What it means is we need very small amounts of it in order for our body to function normally. All right. For the most part, most trace elements now are added to food. If you check nutrient labels, you'll see addition of things like iron or iodine to food products, okay? Copper and zinc are another couple common elements that are sometimes added to food because we need a small amount of that typically to prevent other deficiencies within the body, okay? But in terms of that, what we're talking about here, on basics, all right, if I go back to this, is we're talking about all of these chemical structures that are elements, okay? And in terms of that element, okay, elements are the basic building blocks for what we need chemically to run all of those chemical reactions within the body, all right? Elements, you can kind of think of those as the basics, all right? We've also got compounds, okay? Compounds are elements that come together. And I should put this really, typically you've got two, you may have more elements that come together, okay? Compounds tend to be more common than elements in the environment. And we'll talk about why when we break down the components of an element, because we're going to break the components of that element down into the atom, and we'll talk about the electrons, the protons, and the neutrons that make up the elements, okay? But in terms of compounds, all right, an example of a compound involves sodium. Oh, me and my spelling. Goodness. At least I realize I'm spelling it wrong. We've got sodium and we've got chloride, okay? Either one individually is very, very reactive. If you had a chemistry professor who brought in a little elemental sodium is a metal, it's a solid, and if you put that sodium into water, you get a huge reaction, okay, out of it, all right? And that seems like, whoa, that's not something we want to put in the body. But if we combine sodium with chloride, okay, this is now a compound. And the component that makes the sodium and the chloride very reactive has essentially been neutralized, because what we've done is we've formed a bond between sodium and chloride, and now that's much less volatile, all right, although it still has the ability to react, all right? And I pick on sodium and chloride because this is our common table salt. Brings us back to iodine, right? With iodine being added to table salt, okay? The iodine doesn't interact with the sodium chloride. It's going to be independent of it because the sodium and the chloride have already made a compound, okay? So we're talking about compounds, all right? You can also have molecules, okay? Molecules are really longer chains or larger structures that are put together from elements, okay? An example of a molecule that we'll talk about this semester, deoxyribonucleic acid. DNA is a molecule. It's made up of carbon, hydrogen, nitrogen, oxygen, okay? Oddly enough, those four that I want you to know. It's also got some phosphate associated with it, okay? But in terms of that, when you take multiple elements together and build them into larger structures, when they become larger structures, they become molecules, okay? So in terms of that, that's where I'm going to wrap up this particular portion of this. The next video I'm going to talk about, we'll talk about the components of the elements. So essentially those elements are made of atoms, and those atoms that we're going to talk about are going to be the electrons, the neutrons, and the protons. All right? So thank you for your attention. Please let me know if you have any questions.